Right, let's have a little look at balancing equations. Here we have one single atom of carbon solid, and we're going to add one molecule of oxygen, and it's going to give us one molecule of carbon dioxide in gaseous form. If we were to do our balance here, the only elements that we have here are carbon. On this side we have one carbon, on this side we have one carbon. On the left-hand side we have two atoms of oxygen in the oxygen molecule, and we have two atoms of oxygen in the carbon dioxide molecule. So this particular equation is balanced. We don't actually need to do anything. The important thing here is to make sure that the number of atoms on the left-hand side equal exactly the same number of atoms on the right-hand side. Otherwise our equation isn't balanced and it will be incorrect. We can't change the subscripts here. They are the same. You can't change the carbon dioxide, you can't change the oxygen. This is the chemical that it is, and if you change that number, you're actually changing the chemical. If we're trying to balance equations, the only thing we can do is balance by changing the number in front of the atoms. We could have balanced this equation by taking 2 of everything. For example, that would give us 2 carbons, 4 oxygen molecules on the left, 4 oxygen on the right. But then we can see that we have a number 2 in front of each of these, which is incorrect. We can simplify this equation by dividing each of the subscripts by 2. So let's have a look at a few more equations then. What about if we have magnesium, solid, the metal, and we burn it in oxygen to give us magnesium oxide, also a metal. Now, how do I know it's MgO and not Mg2O? Well, I know that magnesium is in group 2 of the periodic table, so I know that it is hankering after 2 electrons, which it will easily get from, be able to give away. It wants to give away 2 electrons to oxygen, and oxygen is missing 2 electrons. So it will form the ion magnesium oxide. Okay, let's have a look at balancing this equation then. Well, we can see that on the left-hand side we have 1 magnesium, and on the right-hand side we also have 1 magnesium. If we look at oxygen, on the left-hand side we have 2 oxygen atoms, and on the right-hand side we only have 1 oxygen atom. So this isn't balanced, so we need to double up on the left-hand side by putting a big 2 here in front of the magnesium oxide. But now the magnesium isn't balanced either, because this also has 2 on the left-hand side. So in order for the equation to be balanced, we would need to put 2 parts of magnesium. What's this actually telling us? Well, it's actually telling us that if we want to combine magnesium oxygen, we need twice as many magnesium molecules, magnesium atoms, as we do oxygen molecules. And that's a very important concept, and we will talk about that a bit later. Let's look at a few more equations to balance. Well, here we have the chemical copper carbonate. And if you heat it very strongly, you will get the copper carbonate to turn into another chemical, copper oxide, and it will give you off carbon dioxide gas. So let's start by balancing. We start with our copper, and then we will start with our carbon. The reason that I take carbon before the oxygen is actually that carbon is only in one place here on the left and one component here on the right, whereas the oxygen is in several places, so I'll finish off by balancing the oxygen. If we look at the number of copper atoms on the left, we have 1, and on the right also 1. If we look at carbon, we have 1 on the left and we have 1 on the right. And if we look at oxygen, we have 3 on the left and 1 2, 3 on the right. So this equation is actually balanced already. We don't need to do any more with it. Let's look at a few more where we actually do need to do something. Well, let's look at the reaction here where we take iron oxide, which is iron ore, and at very high temperatures with a catalyst, we let carbon monoxide go over the iron oxide so that we can extract iron. And if we start here, we have iron occurs once on both places, carbon occurs once on both places, and we will finish off by balancing the oxygen. If we look here, on the left-hand side we have 2 iron, and on the right we only have 1, so we need to put a 2 in the front to our iron. Then we look at carbon. We have 1 atom of carbon on the left and 1 atom of carbon on the right. And then we look at our oxygen, which on the left-hand side we have 4 atoms of carbon, and on the right we have only 2 atoms of carbon. So, of oxygen, sorry. So we need to balance up the oxygen first by multiplying by 2. This will give us 4 on the left-hand side. This also doubled our carbon. Giving us 2 here. But now we have to recheck our oxygens again, because now we suddenly have 5 oxygens on the left-hand side of the equation, and still only 4 on the right. So that was not correct to multiply the carbon by 2. We have to try and find another number that will help us balance our equation. So we will then try 3 molecules of carbon dioxide, giving us carbon is now 3 on this hand side, and oxygen is now going to be 2 times 3 to give us 6. We will need 3 carbons here on this left hand side, so we now have 3 carbons on both sides of the equation. On the right hand side of the equation we have 6 atoms of oxygen, and on the left hand side of the equation we also have 6 atoms of oxygen. So our equation is now balanced. So 1 part of iron oxide combined with 3 parts of carbon dioxide will give us 2 parts of iron and 3 molecules of carbon dioxide. Let's look at some of the acid-base reactions that we've looked at. Hydrochloric acid plus magnesium metal will give us a salt, magnesium chloride. But I know that magnesium is in the second group of the periodic table. It will produce a magnesium ion with 2+, so I'm going to need 2 chlorine ions to balance the 1 minus the electron that the chlorine is missing, and hydrogen. So let's have a look here. If we start with hydrogen, and then we can have chlorine, and then we can have magnesium. On the left hand side I have 1 hydrogen atom, and on the right hand side I have 2. So the first thing I'm going to need to do is double up my hydrochloric acid to give me 2 on each side. I then look at my chlorines. Well, on the left hand side I already have 2 chlorines, and on the right hand side 2. And my magnesium, I have 1 atom of magnesium on the left and 1 of magnesium on the right. So my equation is balanced. Let's try another one. Let's say that we have sulfuric acid, H2SO4, and we add some magnesium metal to that. What is going to happen? Well, it's going to film the salt, magnesium sulfate, and hydrogen. I know that sulfur, the sulfate ion, must have a valency of 2-, because I have 2 hydrogen atoms and each one has 1 plus. And for this chemical to balance, I must need 2 hydrogens with giving me 2 plus and 2 sulfates giving me 2 minus. So I know that this equation must be correct. So let's have a quick look at what we have here. Hydrogen will keep the sulfate together as SO4 because it's in the same form on both sides of the equation, and magnesium. I have 2 hydrogen atoms on this side and 2 on this. I have 1 sulfate ion on this side and 1 on this, and I have 1 magnesium on here and 1 here. So this equation is balanced. So this gives you a quick introduction to balancing equations.